Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining us today is Tobias Fenster. Hey, Tobias, how are you?
Hey, I'm fine. How are you doing?
Good. I know, folks, that Leslie is advertises doing this, but she wasn't available, so I'm chipping in. Hope you're not too terribly disappointed to have to see my beautiful face instead of hers. But more importantly, we have a guest, Tobias, and he's going to talk to us about containers. We're going to build .NET apps and we're going to run them in containers. So we're going to talk about what are containers, why are containers. We're going to look at how to do it, and that's what we're going to be doing today. So before we begin, Tobias, a brief introduction on who you are.
Yeah, so I'm, as you said, Tobias Fenster. I'm from Germany. On the business side, I'm a managing director of 4PS in Germany. It's a company that builds an ERP system for the construction industry. So very much on the business application side, using the Microsoft stack. And on the community side, I'm a Microsoft MVP for Azure and for business applications, a regional director, and I'm also a Docker captain. So that's
Ooh.
why containers is really something I'm very passionate about, and I've been working working with for the last couple of years.
Okay, so I know that you've been able to run .NET apps in containers for a while. Excuse me, I've played around with it, mostly in Visual Studio. I know that there's been a lot of advances in terms of the .NET team has done a huge amount of work on working with them. The toolings come a far way, but let's start off with, why do we care? Why do I as a developer care?
Yeah, absolutely. I mean, the basic story of containers that hasn't changed since the early days, especially since Docker has made it mainstream available for most people. And the basic idea is that you have something that allows you to really package your application in a way that allows you to run it in a lot of different places, allows you to make sure that it runs in exactly the same way in different places, so that you don't have the good old runs on my machine problem where the developer creates something and then puts it in QA in a QA environment or something like that, and suddenly it doesn't work anymore, and you have to figure out why, or even worse, it runs in QA but doesn't work in production, so that you really have a very stable and consistent way to deliver your applications, really the minimum required things that you need for your application, and make sure that it runs in the same way across different environments, development, QA, production, and so on, and make it as easy as possible for an operations team to get it up and running.
So your container is basically a self-contained environment, operating system, software, everything you need. Once you get that working fine, you can move it around, run it various places, and it never changes, so it's always going to work. Is that the basic
Exactly.
idea? And then you, of course, can update it if new versions of the software come out, or there's updates to or patches to the operating system, but you have this thing that is always going to work regardless, right?
Yeah, absolutely. Of course, as always, there's exceptions to the rule. So sometimes you find those corner cases where something breaks. But in general, I think your chances, if you run it in a container, you put it in a container image, and then you run that image, which gives you the running container, your chances are a lot higher than it used to be in the past, that you're really sure that your application is running.
Okay, and then this is a good lead into what could be our next question, minimum memory requirements. So I guess another way of saying this is, rather than run something on a server, I'm going to run it in a container that's running on a server. How does that impact resource requirements, not only memory, but also machines?
Yeah. And basically, there's almost no overhead to running something in a container. That's one of the beautiful things. If you think about the analogy that is oftentimes used between a VM and a container, there you have an overhead because the VM brings its own operating system, and the container, depending on the way how you run it, but is really very, very close to native performance and also has almost no overhead. So there is a slight overhead, but really very little. So my best advice always is size it as if it was running without a container, and if that works, then you're almost certain that it also will run in a container. So there's not a lot to consider there.
And then it's very popular to run the containers in Azure or any of the other cloud software, but you can also run them internally. Is that correct?
Absolutely. And you can also do things like at home, I have a Raspberry Pi that is running a couple of containers. So you really can downsize a lot, use it on edge devices where you really have restricted environments, but you still want to use the benefits of containers. So absolutely possible to also use it in quite restricted and low resource environments.
Cool. All right. Let's see how you do one of these.
Yeah. Let's give it a try. So the first one, I guess, would be to run a hello world because we're in IT. So definitely let's try that.
I should probably. All right. So are you sharing?
I was trying, but let me try again. It says stop screen, so I hope I'm sharing.
I don't think so.
Okay, then let me stop and try again. Sharing is opening.
Oh, you might have been. That might have been my error.
Let's see. I hope I'm sharing again.
You were. That was my fault.
No worries.
Here we go. I've only used this 100 times, but I'll figure it out one of these days. Okay.
Okay. Yeah, so first try, basically, I should start off with saying that I've installed Docker Desktop on a Windows VM in this case. Could also have been my laptop, but just to make sure that the demos works nicely, I put it in a restricted environment as well. Have it in a VM. Docker Desktop is installed, as you can see in the background here. And as always, the first thing to do is a hello world. So let's do a Docker run, which means we want to run a container and say hello world. And now you can see, okay, it can't find the image. So basically the definition of what the hello world should do. And you can see that it's immediately pulling it from a central library or a repository. It sees that it has already had parts of it, and some of it had to pull, so basically to download. And then it says, okay, I've downloaded the newest image. And here you can see an example of a very simple container that just outputs some text messages. So basically, this is my container that says, hello, I have a Docker client, I have a Docker daemon, what happens, and so on, and what might be next steps. So that's basically the easiest way to just run a container.
So their containers are sitting up in a repository as an image. So your Docker desktop, you said run this hello world. It said, I know what that means. It went out to a repository somewhere managed by Docker, pulled down a bunch of stuff, this image, and then Docker desktop can run containers locally for testing purposes, basically, right?
Yes.
How big is that image? Came down pretty quick.
Please.
How big is the actual image on disk?
Okay. Yeah, good point. We can see here the hello world image has a size of 292 megabytes. But the interesting thing is those 292 megabytes, if I click on that, we can see that it has used a base image. So that's also one of the features in containers, that you layer images on top of each other. So basically, I've used the Windows Nano server, the Windows base image, and put on that the additional things I needed for the hello world. So you can see that I already had the first layer. Let me quickly switch back. So you can see here, the first one I already had. So I cheated a bit and pre-downloaded the Nano server image. And that has had 292 megabytes. And then it only downloaded 2 times, basically 40 kilobytes. And that's why it was so fast to start, because it only needed those additional layers here.
And how big is the Nano server image? Is that
Nano server total is 292. Oh, wow. So that's you can see it here. Yeah. There we have the 292.
And you've got some other Windows server images that are 4 or 8. So they can be fairly sizable if you get a full-blown Windows server running, right?
Absolutely.
Okay.
Yeah, that's one of the big differentiations when you look into Windows containers compared to Linux containers. The Nano server has come quite a way. Less than 300 megabytes is not great in the Linux world, but it's kind of acceptable. The other ones are really big, and you need to plan for that and be sure that you have enough time to pull those images and run those images. So it's just, yeah, a bit more resources and overhead that you need to think about when you use Windows containers.
And I know is it still trying to, it used to be true that it was very popular to run containers in Azure using Linux or Ubuntu because it was smaller than Windows. Is that still the case?
Absolutely, 100%. So just the same thing I can do on my desktop here. So if I just do a right click on the little veil here, which is the Docker logo, I can say switch to Linux containers. Actually, before I do that, let me show you one thing. If I do a Docker version, then I can now see I have the client side of Docker, and that one is basically running on Windows because I'm running on a Windows machine. And we have the server side, which is also currently running on Windows. But I can switch that if I just go here and say switch to Linux containers, accept this message. And now it has already switched. If I do a Docker version again, you can see the client is, of course, still Windows, but the server now suddenly is Linux. So now it's using the Windows subsystem for Linux in the background. Docker Desktop sets that up automatically. And then I can get started with Linux images. So if I now, again, do a Docker run, basically the same thing is happening, but now it's not pulling the Windows image, but it's pulling the Linux image, and it's running the Linux image in here. The output is slightly different. And if we take a look at the images, let me filter this a bit, you can see now we have an extremely small image. It's basically doing nothing, but that's the way how you can do it with a Linux image.
Cool. All right. JC, I see you have a question, but we're going to get to that a little bit later on after we actually build it out. So stay tuned. All right. All right. So now what? So we've proven that we can run containers, but we're going to build a .NET app. We're presumably going to make our own containers. So that would be the next step, right?
Absolutely. That's the idea. Right. So, and I really wanted to show you basically from scratch, from a .NET New, how this works. So let's do a .NET New Web API, call it VS Toolbox. Go into that folder and open it up in Visual Studio Code. So this is just your regular web API running the weather forecast service as it comes out of the box for .NET New. And now the easiest way to bring this into a container is something that the .NET team has built very recently, which is that without having any knowledge about how a Docker image is constructed, without even having to install Docker, which I have because we're going to take a look behind the scenes basically. But what I can immediately do is I can do a .NET publish, say that I want to have it for Linux or x64 architecture, and I'm going to use the publish container target in a release configuration. And what this now does is it does the regular restore and build. So basically what you're used to from .NET, but it also is immediately creating a Docker image for me. So again, without having to know a lot, it directly has created that image to use. And it has what it says here, as you mentioned before, there are registries, and it has pushed this to my local registry. So if I now go into my list of images and no longer search for hello, but for VS Toolbox, you can see this is the image that has been generated 12 seconds ago. It's a rather big one because it has the whole .NET Core framework and so on. But this is something that I can use to immediately get started and run that container. So now, as we've seen before, the .NET run for Hello World. Now we don't want to run the Hello World, of course, but we want to run our application. So we do a .NET run again, and we want to reach it via the network. We can take a look at that a bit later, how that works. But for now, let's just say VS Toolbox. Oh, no, it's, of course, not a .NET run, but a Docker run, because we want to run the container now. And here I can see basically the logs from the container, so what it does when the container has started. And if I now go to localhost 8080 weather forecast, I get the application. So this is basically now already talking to my application inside of the container.
Holy cow. And you didn't need to know anything about Docker config, those there are XML files or something that told how to build things and all of that. This just wraps that up for you.
Yes,
Cool.
absolutely.
All right.
If we take a look at the image in Docker Desktop, we can even take a look at what has happened behind the scenes. So we can see that it's now built on top of a Debian image, Debian Bookworm, which is the new default since .NET 8. We can see the commands that it has created for that particular image. So we can still kind of take a peek behind the scenes, but we don't have a lot of control there. Of course, a ton of parameters that we can use to configure things, but still, this is basically more for people who say, I know I need to run this in a container. Maybe my, I don't know, ops department tells me to run this on Kubernetes or whatever. So we really need to have it in a container, but I don't have the time, I don't have the bandwidth or whatever to get to learn all of this. So then this already provides a great way to get up and running, to get started without having to worry about a lot. It adheres to a ton of best practices. It's a good image. So this is really something, if you need that quick start, if you want to get started with containers right away, this is a really good way. And I think the .NET team has really done a great job in that area.
Yeah. And then you could publish this to Azure, run the container in Azure from here as well?
Absolutely. You could push it to a public registry. So now this image basically is only known on my laptop or on my VM. I would need to publish it to some kind of a registry, either a public one or a private one. And then we could instruct things like Azure Container Apps, Azure Kubernetes Service, whatever could run a container, to take a look at that registry or that repository, pull that image, same as we did locally, and just run it. So that would then also be ready to run in a cloud environment.
Wild. Cool. And then it's running in a container, but if you run it and debug it, you can set breakpoints and all that just as easily as if it was running locally, right?
Yeah, that actually is a bit more difficult, because this one, how we've set it up now, basically is a configuration for a release mode. So we have the limitations when you run it in release mode. Okay. And you would need to find a configuration how to connect your debugger to that container. There are things like the Kubernetes bridge that you could use to run it locally, but still kind of in a Kubernetes cluster. So there are ways around that, but it's not as easy as if you would have it running locally.
But you could run it instead of creating the container, running the container debug, you could have run it, instead of doing it release, you could have done it debug and then debugged into it, right?
Yeah, then you would need to figure out how you connect to it and get the connection, because the container would be running somewhere in Azure. But still, yes, you can connect to it and get that, make that happen. Yeah.
If you're running it locally, it's easy to debug and hit breakpoints and all that, right?
Yeah, there's even a whole concept that is called a dev container. There, the idea is, what we're now looking into is more like, I want to run my application, but there's also a whole ecosystem, mostly, I would say, driven by Visual Studio Code dev containers, that allows you to set up your whole development stack in a container. So basically, the idea is, I need .NET, I need this, I need that in a specific version. How do I set it up? Where is this documented? I'm switching between projects, I'm changing teams, I'm onboarding new people, always the same challenge. And there, the idea is to put your whole development stack into a container, run that, and then have Visual Studio Code, the server component of Visual Studio Code, basically run in there as well, connect to it, and then you're running in a container. You have everything predefined, everything standardized, but you have the same debugging, breakpoint, etc. experience as if you would be running it on directly on your machine.
Yeah, because I would imagine the workflow is you build the app, you test it, and the app now works, and then you want to put it in a container, but you still need to test it because you don't want it ran on my machine, but now it doesn't run in a container problem. That just shifts the problem to a container, right? So you should, I would imagine, run your same suite of tests in the container, and then be able to debug and make sure it works in the container. And then once you have it working in the container, then it's totally portable. But you got to make sure that it's running in the container first, right?
Yeah. What also happens quite often is that you, in your CI/CD pipeline, so when you do a build of your application, you do the build, but you actually do it already in a container. So you don't have to worry about setting up the SDK and all that. That's automatically handled by your container image. Then you do the build in the container, and then you also run the test there so that you're, as you mentioned, sure that you're not just shifting the problem, but you really make sure that the container image is exactly doing what you want it to do.
Okay. Cool. All right. What else as just the basics do we need to know about this?
Yeah, I mean, the next step now would be to take a bit more control. So instead of just letting .NET completely do it, it could be interesting to take a look a bit more into this. And what Docker offers here, it's also possible to do it in different ways, but we could do a Docker init. So this is basically now looking into my application and telling me, okay, what you probably want to have is a Docker ignore file, a Docker file, a compose YAML, and a README. And we'll take a look at all of those. But the important thing is it has already figured out that I'm doing something in .NET. So it says it has detected that I should use ASP.NET Core. You can see here there's tons of other programming languages and frameworks and so on. So, okay, I use that. The name is VS Toolbox of my main project. Version is .NET 8. It already has seen that as well. The port I want to use is 8080. This is the default now for .NET 8 in containers, so that also makes sense. And then it says it has created all that stuff for me.
So we didn't have.
So if we take a look,
we didn't have those files before.
Exactly. It has created the Docker file. It has created the compose YAML. It has created the Docker ignore. And if we take a look at that, it is. Let me close that down for a moment. It is using a slightly more complex setup than what I would need if I want to take it from scratch. So maybe we can also do that in a second. But to walk you through this, it first uses the SDK image, as you can see here. So it has the full .NET Core SDK. It uses a copy command here. So it copies in the sources into a source folder in the container image. It changes the directory to that folder. I can do multi-architecture builds if I want to use AMD and x64 and so on differently. Then it does a .NET publish, potentially also mounting a cache layer here using a runtime. It doesn't use self-contained because it's put in a container anyway. And then we basically have the publish done. What I then can do is I no longer need the SDK. And as we discussed before, I want my image to be as small as possible and only have the required things in the container image. So I no longer want to have the SDK, but I can use a smaller image here, .NET ASP.NET, which is a stripped down version that only has the runtime. So I'm using that one. I'm just creating an app folder. And now I'm copying from the build image that we've seen before. So if you remember here, we said we want to do a .NET publish and put it in the app folder, but do that, and I'll scroll up a bit in my build container. And now I can see, I can do down here a copy from a build into that app folder, everything that we found. So basically, we use the SDK container image to do the compilation, to do the restore, to do the publish. And now we put it into that ASP.NET image that only has the runtime. We have the compiled result and put that in here. And then we run it below here. So we're just doing a .NET VS Toolbox.dll. So we're running the application. And for security practice, it also makes sense to use a non-privileged user. So we're not running this as root. And that's the reason why we have this command over here. There's a default user that is that is part of the standard .NET images, and I can use this variable app UID here to reference that user. And if I now build this and run this, then we will have an application where it's not running as root for security purposes, and it's also a quite small image to use that.
So before you did this, you just
Yeah.
in
Let me just quickly run
one line of code, you created a container and it worked great. And now you got the Docker file and the compose YAML. So when would you decide that you want to make it harder?
Fair question. Absolutely fair question. And as always, if you're fine with the defaults, if you're fine what comes out of the box, then you're absolutely good. But let's say I have something where I need to install an additional application. I need a dependency. I need some additional tool that is needed to run my application. Now I could use the Docker file to say something like, install this application, please, or I need to do some other preparation work.
Third-party dependencies like various controls, right?
Exactly. Yes.
See, I told you we get to your question at the right time. Okay, so that you would specify inside the Docker file to register various dependencies and other things, right?
Yeah, I mean, if it's part of the project definition, if it's just a NuGet package, then we can just pull it from the restore and then the publish. But if we need to install an additional library, an additional dependency, then this is something that we would need to do in the Docker file.
Okay, got it.
Yeah.
Cool.
So to just quickly walk through that one, we have the Docker file now. So we can just do a Docker build. And there you can see already how it works. So it's now pulling stuff. It's bringing in the sources. It's now doing the .NET publish as step number 4. So the steps you can see here. We can see we're running in the build over here. And it's running the second of 4 steps. So if we take a look again into the Docker file, we are in the build over here. And then we have the copy as a second step because the from basically is the first step. Then as a third one, we have the work dir, and then we have the run as the last one. So this is basically where this correlates. And if you see those numbers and those identifiers, then we can quickly take a look at that. So basically now we have created a new image, VS Toolbox version 001. Now if we do the same Docker run again, but now we use 001. This is now not using the image that we had .NET generate, but this is now the image that we created using our Docker file and the Docker ignore and all those things. So if we again take a look into our application, that still works.
Yep.
And if we take a look into Docker desktop in the images, you can now see we have version 001. And this one now already is quite a bit smaller, as it using a bit more of an optimized version here.
Cool. Very cool. All right.
Yeah. So this is basically how you generate it. We could go into a lot more detail into what you can do with a Docker file, what you can optimize, and so on. But I think the key things to take away from this, if you create it and if you intend to run it in production, then this structure of having a build stage that has the SDK and then also a runtime stage that only has the runtime. This is a very good practice also to not run things as a root user, but instead, for example, here in the .NET image, we can use the app UID that comes predefined so that we're sure if something happens, if someone finds a bug, finds an issue in our application and manages to break out of that, then the attacker is still not root. So they're still pretty limited of how much they can do with such an environment. And that's the reason why you want to do that. And then there are a couple of other things. What I also wanted to briefly show you is you can see the little squiggly lines here. And this is something that the Docker AI extension is using. So if we take a look into VS Code here, you can see I have installed the Docker Microsoft extension, but I've also installed the Docker AI extension. And that one gives me basically those little tips. Okay, I could also use what's called a digest, do a quick fix, and say pin okay, that's not available for that one, but if it was available on the Docker Hub, it would give me an immediate digest. So it's not only pinned to 8.0, .NET 8.0 on Alpine, but I really would pinpoint it to a specific build. So if I'm running in an environment where I really want to make sure that always the same versions are used as base images, then I can even pin it to a digest, or I can take a look at that one here. Yeah, it says that I might have an issue with string replacement. As we've seen, it works in this case, but this just gives you an idea of what you can do with Docker AI to also help you when you're working with those Docker files, to get those little tricks, to get those little best practices, especially from a security perspective, but also from a structurally perspective, that you then can use and apply and make your applications in those container images better.
Cool. So I think JC has a follow-up question about dependencies. Can the container take advantage of dependencies registered outside the container?
There are ways how you can make the container interact with the host system. So the host basically is the VM, the laptop, whatever is used to run the container. And you can do things like map a pipe into the container named pipe, or map a folder into the container. So assume that you have installed something on the host that is sitting in a folder. Then you can map that folder into your container and then use those files. Of course, if those are Windows files and you're running a Linux container, then you have an issue. So it's not that flexible, of course. But if the operating systems match, then you can do that and map, for example, a folder and use those dependencies that you have on the host. Generally speaking, you typically try to avoid that. There are, of course, scenarios where it's perfectly possible and makes sense. But generally, you try to put everything that you need for your application to run into the container image, so you have that transportability, that flexibility that we mentioned before, that okay, if I'm running this image, it's working, and I don't necessarily want to depend on something outside of the container.
Yeah, because that's right. That kind of degrades the concept of immutability and portability, right? If you take a container, move it from one server to another server, but that server is not set up the same way, then the app's not going to work right, which is not what you were hoping to get in the first place. So you would need to be careful about that.
Yeah.
Ideally,
what is interesting to mention maybe though is that if you delete a container, you also lose the file system inside of the container. So basically, imagine something like a SQL server running in a container, and you do something with your database. Now you delete the container, your database is also gone. So what you could in that scenario do, for example, is to map a volume or a storage area into your container. That could just be a directory from the host, or it could be a bit more complicated setup. But you basically then have some kind of storage that is tied to your container. But if the container is deleted, you still have the storage area. So in that way, you're safe from losing data if you accidentally delete the container or something like that. Or, for example, if you need to throw away the container and start from scratch again, then you might still have your database or whatever was stored in that persistent storage area. So in that scenario, it makes a lot of sense to have some storage connected to the host as well. Not for portability reasons, but really to make sure that you persist that kind of data.
Right. So Napalm Code says, works on my machine has now become works on my Docker runtime. Which, to a certain extent, you disappeared.
Oh, try again.
To a certain extent, that's true, obviously, but if it works on my runtime, if it works in the container and you can move the container around, then you've dramatically reduced the possibility of it not working from one place to one place. So if it works on my machine and I copy it to another machine, then there's a potentially big problem of it not running on that machine. But if I put it in a container and it works, and then I run it from one machine to another machine, as long as those machines run containers the same way, then I'm not going to have the issue of it stopping working. So I think that is a true statement, but you do get dramatically reduced risk of it not working.
Yes, absolutely.
All right, cool.
Just a bit of my past. I used to work with data centers and help people install more or less complicated applications, and that always was a hassle. Yes, you could use VM images and that kind of thing, but that was really a lot more work than as soon as we moved into containers and we were able to share container images. That became dramatically easier than it was before.
Right. Cool. All right. What do we want to see next?
Let's see if we get any comments. But otherwise, I can also maybe share with you what we've done initially. Where's my mouse pointer? Over here. Because I just did that -P 8080 to 8080 thing. And what this is, it shows you how you can interact via the network with your container. So what this does is basically maps port 8080 in the container where my application is running, as you can see here, to 8080 on the host. So now I can reach 8080 in the container through 8080 of the host. That doesn't necessarily have to be the same one. So we could also do something like, let's map port 8082 to 8080 in the container. So this is now in the container, it's still 8080. But if I go in here and try to connect to it, you can see the little loading thing spinning, and it doesn't have anything. If we use 8082 like we've now configured, then we're back in action. So this is basically the way how we can access the environment from a networking perspective. The other thing that we can do is we can do a Docker PS. That way we can see the running applications. So we see here, this is our, let me make that a bit bigger. You can see here, this is our VS Toolbox 001 image, and that has an ID of 7A1 whatever. And now we can do something like Docker execute in that container, and we're on Linux. So let's use a shell and make it an interactive terminal. So now we basically have a shell inside of the container and can move inside of that container and do things that we want to. If you remember, we created that app folder that has our application, but it of course has a total file system that is completely disconnected, or not disconnected, but separate from my host operating system, which, if you remember, was actually a Windows environment. So this is a way, if I need to go into the container, maybe run some debugging commands, take a look at the files that have been generated or something like that, then I can do that and get that access here as well. Or if I, for whatever reason, lose that Docker run that has the logs, I can also do something like Docker logs of that container, and then I still see the logs. So I still have access to the logs. I can access it via the network. I can have files. I have console access, and so on. Those were just the Docker commands. Again, if I want to make my life a bit easier, I can also go into Docker Desktop, select my VS Toolbox container, that one over here. There I immediately get the logs. I can take a look at some metadata, etc. I can do the exec, which is the same thing that we just did in our console. I can take a look at the files. There I can also see which files have been changed since starting, and so on.
Oh, sweet. So if your app is logging errors, it's logging it inside the container, and this is how you can go in and look at those logs, among many other scenarios.
Yeah.
Cool.
Yeah.
What is the role of flamboyant bratane? You didn't come up with that name.
No, absolutely not. Those are randomly generated by the Docker engine. So whenever you create a new container, you can also use the name parameter if you want to select the name basically and define something that's more speaking to you. But it also generates those names randomly.
Okay.
And it's always some kind of an, I don't know what the word for that is in English, but yeah, you can see it's always some kind of famous physician or something like that. Yeah.
Yeah. Okay. Cool.
Yeah. And there's even, I would need to look this up. I think there's a line of code in the runtime that makes sure that you never can do a boring Wozniak. So Steve Wozniak is also in there as a name, but you can't do boring Wozniak. And there's a comment that says something like Wozniak is never boring, so that can never happen. And that's the one combination that you can't hit, and everything else is possible. So you can do boring Einstein or something like that, but you would never get boring Wozniak.
Fantastic. Cool. All right. So is that, I'm just looking at our show notes. Is this under interacting with containers?
Exactly. That's what I wanted to briefly show, how you can interact with your containers.
Okay, awesome. And you can do that whether this container is running locally or somewhere else, right? Is that
if
true?
It's running locally, then you can do it like this. This is basically the easy way. But if it's running somewhere else, there's also typically options to go there. It's maybe worth mentioning that there are also environments where basically no shell is installed or no PowerShell on a Windows container. So those really are trimmed down applications that make sure that nothing is in that image that might be usable by an attacker. So it doesn't even have a shell. And if there's no shell, then I also can't do an exec, for example. Then I would need to use different mechanisms to go in there. But generally speaking, yes, most of the environments have something that allow me to have that kind of access. Definitely the logs, typically also the access to a shell in some way.
All right, cool. Cool. All right. I think we're good on comments. We're going to talk about optimizing for production readiness, right?
Yeah, that would have been the next idea. We actually already saw a lot in the generated Docker file here. So as I mentioned, you want to do this multi-stage approach where you have the SDK here, and then in a later stage, you have only the runtime. For production readiness, you also want to make sure that it's not not the root user is used. So that's also something that's important. Maybe for production, it's also interesting that you can use environment variables for configuration. So if you do a Docker run with an environment variable, then that one will also be picked up by the container. So let's go back in here. Let me check. We have the running one here. So if we do a Docker run, a -e, which is I want to pass in an environment variable, then we would do an ASP.NET Core, what's it called? Environment, I think. Development. Then we would get this as a development container. And I think this should also now give us a Swagger UI. Yes, exactly. So if we take a look at the code in the standard web API example, we have this one here. So if the app is running in a development environment, then we want to have Swagger and we want to have Swagger UI. So because we are now running this in development mode, this has happened. If we shut it down again and run it without that parameter, then it's in production mode again, as you can see here. And if I try to reload here, Swagger has disappeared because now it's running in production. So this is also one of the mechanisms that you want to make sure that you don't, hard code things in a config file or something like that. And then you have different images for production or for development, because at some point of time, probably your development image will run in your production environment anyway. So just to make sure, use the standard configuration mechanisms that you can use in .NET. Those easily work within a Docker container through those environment variables as well. And then you're sure that you're not putting in anything that you don't want to have there. And the other example of that is the Docker ignore file that, if you remember, was generated for us earlier as well. And that is basically a collection of files or wildcards, files with wildcards, as you can see here, that will not be put into the container. So if we do a Docker build, it basically looks at our folder or the directory we're currently in, puts that in what is called the build context, and then creates the container for it. So if we copy in everything that is in the build context, we might end up putting in something that's in a development app settings file or a secret that we have put somewhere or something like that. Right. And by making sure we have that Docker ignore file, that just removes everything that might be security relevant, so it never ends up in our container image. And we don't, have some secret or something I really don't want to share be in the container.
So it kind of serves the same purpose as that git ignore file, right?
Stuff exactly.
That's checked into your source code repository. Cool.
Yeah. 100% the same idea. Yeah.
Nice. All right. Cool.
Yeah, and then we can even take it further by using those, as I mentioned, those slimmed down environments. So if we go back in here into the Docker file, you can see here we have ASP.NET, the 8.0 Alpine image, which is the standard image. What we can also do is, and that's also new since .NET 8. I think previously they were shared somewhere as a preview, but since .NET 8, I think they're publicly shared, and I hope I didn't mistype that one.
Where do you find out
see
those?
If we... Yeah, let me briefly give it a try, and then let's see, that's already done. And then try to run version 0.02. Let's see whether it still works. Try to get our weather forecast again. Yes, that works. And if we now take a look at the image here, our version, oh no, those are the containers. I wanted to look at the images. You can see it has gotten a bit smaller even. So we were at 161 megabytes. Now we are at 148 megabytes. And one of the important differences is that if we do a Docker PS, we see our container here. So this is running the 002. It has an idea of B26. So let's try the Docker exec B26 shell again. And it says can't do that because it doesn't have a shell. So this is an example of a base image that is really completely chiseled, as the name says. So it's really slimmed down. It's actually an Ubuntu base image, but they have provided those base images that are really down to the absolute requirements, and it doesn't even have a shell installed. So if a hacker would be able to break into that one, there's actually nothing they can do. Of course, the counter argument is if I need to run some kind of an application from my application, if I need to run a binary or something like that without a shell, that's also difficult to do. So I'm also paying with functionality for that additional security aspect. But yeah, that's also an additional security measure. If I want to put this into production and it's really an environment where I care about security, then this is an approach that I could take. Those images also don't allow you to do anything with root, so I can't even accidentally run this as root user because that's just not possible in those images. So there are a couple of different additional aspects of those images. If I really want to go into production mode and make sure it's really locked down and production ready, then I can use those.
So where's the list of these various images? There was Alpine, there was Jammy, Chiseled.
Yes.
Where is that, and how do we know what they represent?
Yeah. So the easiest way actually is to go to hub.docker.com, or at least that's the way how I typically do it if I'm searching for something. And then I can search here and say I want the ASP.NET image. And it should actually show me. Let me check that I mistype. Or do I need...
And we're looking specifically for the Microsoft ones. I mean, I assume anyone can make anything.
Yeah, that's correct. Let me check. I think I have this in my little... Yeah, indeed, I have it in my little cheat sheet. Not sure why I'm not finding it in the...
Okay, official images for the runtime.
Yeah.
So these are from Microsoft. Okay. And
created by Microsoft, exactly. And then I can see the different versions here. And for example, I can see the information about the chiseled images. And if we scroll down a bit more, then I can see the different variants. It also links to a documentation here that explains the differences. I can see the SDK, the runtime environment, the runtime with dependencies, nightly builds, the full .NET framework. And then here I get a full list of all the images that I can use. If you remember, we used an 8.0 Alpine. So let me see. That
and is
was
there
that one.
a description anywhere of what the difference between these are?
Yeah,
I mean,
so
how do I know
if you
about
really
the
want to dig
jammy
down into
versus
the
jammy
details,
chiseled?
yeah. So if you dig down into the details, you can take a look at the Docker file. And for example, Jammy is the Ubuntu based. So if I look at the operating system version, I can see here, okay, this is Ubuntu, this is Alpine, this is Debian. I can take a look at the Docker files in detail, or I can take a look at the documentation that is managed over here. And there I can see, okay, if it's called chiseled, then it's this. If it's called extra, then it's this. And so on. So I get a bit more information about the different versions that I have in here.
Okay. Cool. Because it looked like there were a lot of different available images.
Yes, absolutely.
So deciding which one to use is going to be interesting.
And the interesting thing here is you can always kind of rely on the details. So let's say if you just, I just want to use .NET 8, I don't care about the details, then I can just use 8.0, as you can see here. And this will automatically translate, in this case, to Debian Bookworm in a specific version. I can also say, okay, I want 8.0, but I want to have it on Alpine. Then this translates to something specific. In that case, 8.02, Alpine 3.19, whatever. So the way those tags are built is that you can always go with as little information as you want, and then just accept whatever the creator of the image has put behind that. Or if you want more control, then you basically typically add more information, and then you get something that's more specific for what you want.
Okay, so let's say I build an app, it's perfect, it's ready to go. I'm told put it in a Linux container. I come here, I see Ubuntu, I've heard that word before. Debian, I think I've heard that word before. Alpine, I thought that was skiing. I didn't know that was a... I like it, so I'd probably pick that one because I'm a big skier, but how would I know? How do I know which one to use?
Yeah, probably you would need to do some web research, to be honest. But if you don't care, just go with 8.0 or 8.02, and then it should probably work. So if you have the knowledge about those different variants, then that's probably because your application relies on some part of that. If your application basically doesn't care about that, then you're probably safe with just going with the default.
Because I would imagine this weather forecast API doesn't really rely on anything that's in Debian versus Alpine versus Ubuntu versus Alpine 3.18 versus Alpine 3.19. I can't imagine that going from 18 to 19 affects our little weather forecast.
Yeah, no, probably not. So I would just go with 8.0. I used 8.0 Alpine. That is used by the standard Docker init because Alpine is a lot smaller. It has a lot smaller attack surface. So in a way, it's by default more secure than the Ubuntu or the Debian ones. So that's the reason why they use that as a default, but you might have different requirements. And again, if you're not sure, then just go with 8.0. You're probably fine.
Yeah. So that answers the question we just got. Excellent timing. So for running on a laptop, is there a Linux distro you recommend? Probably Alpine because it's smaller. Right?
Yeah.
Is that a fair statement?
Yeah.
Okay.
Absolutely. So if you go for smallest, least resource usage, then probably go for an Alpine.
And that's the one that the publish selected by default earlier in the show, right?
Exactly.
Okay.
And then just as always, there's exception to the rules. If we use the jammy chiseled, as you've seen before, then we can even go below the Alpine image. Because if you remember our version 001, just to take a look at that again, the 001, that was the one that had been automatically generated.
Mm-hmm.
And if we take a look at the images, now it's doing a security scan. Okay, if we could look at the image, and our version 002, that one was built on the jammy chiseled. So that one is even smaller with only 12 or 13 megabytes.
Shell,
but
right?
because that's again a very specific version.
But that didn't have the shell,
Exactly.
right?
Yes.
So I think spending 13 megabytes to get the shell is probably worth it.
Yeah, that depends. If you want to go in and do debugging and so on, then it really pays. If you want to run a super secure banking application, then it's maybe a good idea to not have a shell at all.
But don't forget, I'm a student. I'm not running a super secure banking application. I'm just learning how to do this.
That's a very fair argument. Probably not.
Okay, cool. All right. So we're running low on time. We did get a chance to talk about chiseled container images are new in .NET 8, right?
Exactly. They were there before, but just as a preview, and now they are officially published as part of the release. Yeah.
Awesome. So where else would you recommend people go to learn more about this? I think there's some stuff in the .NET docs on using Docker, but where else would people go?
Yeah. I really think in that case, the official documentation really is good, both on the .NET side, where you can learn a lot, and also on Docker, who are doing a lot on getting started. If I go back in here, if you install Docker, and let's just remove everything. Yes, and go back. I'll go back in. I was still searching. Try to delete those as well. Now that's basically what I wanted to show you. If you just enter Docker Desktop, then you get something like, what is a container? A 5-minute course. Okay, something spun up automatically again. Or how do I run a container? This is a 6-minute course, and it has a learning center. And again, the official .NET documentation also has great things on containerization. So in that case, I really would say go for the official docs. There's a ton of content on Udemy and other learning platforms as well. But really, I think the official docs give you a good starting point as well.
All right. Well, thanks so much for coming on and showing this stuff to us. I haven't played with containers in a while. It's great to see how much it's gotten easier. It's gotten more straightforward. It's still all there, but I think it's a lot easier to get started with. That's pretty cool.
Yeah, fully agreed. And thanks for having me. It was great fun.
Awesome. All right, guys. Hope you enjoyed that, and we will see you next time on Visual Studio Toolbox.